so let's actually start getting some ideas of how these surfaces actually work, especially the important ones we're going to deal with. Good news is we're not going to mess with Klein bottles or projective space and with graph theory, at least not unless you want to as a fun exercise. But it is very important for us to understand specifically two surfaces, and we got to start with the sphere. So here's just a starter form of sphere. Usually I pass these around class, but actually I have a graph drawn on here. It's drawn in a kind of a, hopefully a fairly geographical looking way. It's got like a north pole and a south pole, and then 4 points around the equator. And this actually is a Platonic solid, actually, the way that this is represented. This is representing the octahedron. So let me kind of get this drawn here. I'm going to draw this on here. And you should be able to draw this one. This one, there are some that are hard to do, but this one is relatively straightforward. So the way to draw a sphere is, if you're trying to be a little bit artistic here, is anything in the back, kind of do a dot, dot, dot. And then let me actually indicate my vertices with different colors since I have those. Switch markers, stop drawing myself. Alright, North Pole, South Pole. And I'm going to do these 4 vertices sort of, I don't want them to be on the edges. I want to be right here, 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 and here. Okay, these connections I can see are right about here. So I'm mixing my colors a little bit. And then I do have these connections behind, which go dot, 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 dot down here, dot, 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 dot there. And if you're a good artist, you'll add the right amount of curve to these lines, which I don't know that I'm doing. But there you go. It looks a lot like that. This particular graph, drawn without any emphasis that it's being on a sphere, could be drawn this way. Don't worry, I've done this so many times, that's why this is easy. Otherwise, it's like this. Make a really cool logo. It's like a flux capacitor or something. Anyway, this is the octahedron. Okay. Now, this is drawn on a sheet of paper, so think about it being on a sheet of paper. And if you'll humor me, think about it being on a kind of a circular sheet of paper. Okay. All right. So how do we go from a sheet of paper or a drawing on the board to a sphere? All right. Well, first of all, it's good to realize that two actually have a lot in common. All right. Topologically speaking, so in terms of structure. In fact, the only thing that is missing is it feels like, this does feel like the opposite, is that the sphere is more complete than the sphere. The sphere is more complete than the plane. The plane is really just missing a single point. With a single point, you can close up the plane and make it a sphere. And so I kind of use this at what do you call those things? Draw chord analogies. So let me use pink to highlight this draw chord. This purplish, whatever color there. Okay, so again, think about having some picture here. Now what you can do is you can start drawing this chord tighter, and that leaves the plane in sort of this bag shape. Okay, so think about this being a flat piece of paper or something that's kind of roundish. It can be squared, but as soon as you start pulling the draw chord tight, right, the geometry feels like it should be more circular. And then finally, when you pull it completely tight, you end up, with collapsing this to a single point. Okay, so this edge gets collapsed to a single point. All right, this is usually actually referred to as the point at infinity. So there are reasons for this. When you do this with the complex plane, this forms something called the Riemann sphere. Again, you don't have to get too caught up on it. The way that this is done for the Riemann sphere is this uses stereographic projection to pull that off. So yeah, just check that out on your own. I don't want to cover it and make you feel like you have to know it. What you do have to realize is that the difference between a plane and a sphere is a single point, right? So if you just draw the edge up into like a drawstring, you can end up like that. And so one prop I usually bring to class to do that is I have this prop for other purposes too. But you can start with like a flat piece of, in this case, looks like a doily. This is what you do to make a doily. And then you kind of pull the edges up together. And by doing that, right, you pull it until it's almost closed. And then, of course, the final thing would be a complete sphere, which I don't have any reason to make another version of this. You would just pull this tight. Right, it would look like that, right? If I just flip it over. Okay, so here's what's important. Right, so if you can draw embed, right, it's the better word here. Sorry, embed just has one D, it's embedding those two Ds. There you go. If you can draw or embed a graph on a sheet of paper, right, you can be precise, so you mean this in a region of the plane. If I'm just going to say sheet of paper, then you can embed that graph on a sphere. I think the most comical way of doing this that I like to think about is you take your picture on your piece of paper, walk outside, and put it on the grass, right? Ta-da! Right, you've done that. Now it's on the surface of the Earth, which is a sphere. Although you can just think about it as just take a piece of paper, shrink it down to a small size, and put it as like a patch on the sphere. And there you go. You have your embedding on the sphere. It doesn't have to be a big embedding. It can be fairly small. Okay. Now, keep in mind this does meet this. There's this big region, but it's not an infinite region. Okay. Not if it's on a sphere. It's just a big region that seems to be outside of this. You can do the reverse. So if a graph is embedded on a sphere, you can transfer it to an embedding on a piece of paper again, right? It's a sheet of paper. Sorry, piece of paper. Okay, and the way to do this is sometimes I have these balloons, but I think I'm out of them. This is a balloon, but not the right kind. It's a regular balloon. All you have to really do is puncture your balloon. So if you have your picture drawn on that balloon, as long as you don't draw on the knot, you can actually untie the knot, flatten out the balloon. Or if you did draw on the knot, just puncture it somewhere else, rip it open, and smash it flat. Okay, so think about taking your drawing. In some place there's not a piece of graph, right? And so you puncture it there, rip it open, and smash it flat. Okay, that difference between the plane and this closed-up sphere, right, is that puncture point. You're basically removing a point from your sphere. You're puncturing it by removing a single point, and now you turn it into a piece of plane. Right, and that's the difference between a sphere and a plane, is a single point. Okay, it's sometimes called the point in infinity, but you don't have to call it that if you don't want to. All right, this is pretty important stuff. Okay, so the book gets stuck with when they draw something like a graph here. We're going to talk about faces, and specifically you can kind of identify what they are. There seems to be 7 faces here, but that's not true. There's actually 8 faces. If you go to count an octahedron, octa meaning 8, you would count 8 faces on this thing. Same thing up here, right? 4 on top, 4 on the bottom. This 8th face, if you don't work on a sphere, looks kind of special, right? However, if you take this picture and put it on here, it just looks like you took this picture and kind of just slid stuff over. But that 8th face is just a bigger version of the other faces, as long as you're on a sphere. But if you're on a plane, it does look special. So that's the downside to working on a plane and not acknowledging that all of this material actually draws from working on a sphere. So anyway, I'm not taking that shortcut with you, so hopefully you get this connection between the plane and the sphere. Right? It's basically a single point. If you puncture a sphere, you get a plane. If you want to take a plane, just draw the boundary up tight whatever you want to transfer. So this has to be a finite object, right? So draw a circle around it, draw that type, and boom, you have a picture on the sphere. Okay. All right, so up next we're going to talk about faces. We need to get a good sense of what a face is so that we don't think of anything too out of bounds, because it's very important to have a notion of a face. We have vertices and edges. We just need to add that notion of a face, which typically it's not hard, right? These are all good, well-behaved faces here. We need to know what characteristics they have and what characteristics they don't have. All right, so I'll see you on the next one.